Alright, 8.3, number 7. It's an improper integral because we have an infinite boundary of integration. Trying to figure out, so if it converges, figure out what the answer is. If it diverges, then we just say it diverges. While looking at this, I know that it's going to converge because as long as p is greater than 1, it's going to converge on the bottom, and p here is 1.001. So it's just barely, look, if it was 1 over x, it would diverge. But as long as it's 1 over x to the 1.001, it's going to converge. If it was 1 over x to the 1/2, it would diverge. So if p is, just to review, if p is less than or equal to 1, then it diverges. And if p is greater than 1, it converges. Alright, so we know it's going to converge. So now let's see if we can evaluate it. So that's the same as integral from x to the negative 1.001 dx. So, and we're going to find from 1 to b as b goes to infinity. So for my like, you're supposed to do it before we integrate it. If you want to find the antiderivative and then say the limit as b is going to infinity, that's alright, as long as you do it at one point. Okay, so antiderivative of that, we're going to add, so x to the negative 0.001 divided by negative 0.001. We're going from 1 to b. Let's see, dividing by 0.00, so negative, that's the same as negative 1000 over x to the positive 0.001 from 1 to b again. Alright, so b is going to infinity. So I have negative 1000 over infinity to the 0.001. So negative 1000 over basically infinity to 0.001 minus negative 1000 over 1 to the 0.001. So this ends up being infinity in the bottom, so a constant over infinity is 0 minus a negative, so plus, and 1000 divided by, well, 1 to anything as it's not, as long as it's not infinity. Sorry, that was way off. 1 to anything except for infinity is always going to be 1. So 1000 over 1 is 0 plus 1000, which is 1000. So we knew it converged, and now we know what the integral actually gives you. It's 1000.